110 million volts lights up the sky. 110 volts lights up a room. We all know that lightning can kill, but too many of us forget that the low voltage source that comes out of a typical household outlet like this can kill too, if you neglect to follow simple safety rules. You're about to learn how electrical hazards can cause fires, burns, shock, and other injuries, and the steps you can take to protect yourself and others from harm. But first, we're going to take a very simplified look at how electricity travels, because that's where the dangers lie. We all know that electricity and water don't mix, but the flow of water provides a good illustration for how electricity travels. It flows through a wire like water flows through this hose. Pressure pushes water through a hose, and likewise pressure, better known as voltage, pushes electricity through its wire. When the water reaches the end of the hose where the nozzle is located, it must wait for the nozzle to open in order for it to flow out. Likewise, once the electricity reaches its destination, the switch, it waits for the signal to allow it to power the appliance or equipment. Direct electrical current only flows in one direction. However, more common is alternating current, which flows in both directions. Either type can be hazardous to you if it leaks from its path. Why? When the insulation around the wire frays, cracks, or breaks, or a connection is faulty, electricity can leak out or find another path. This is known as a short circuit. If you touch any part of the damaged circuit, the wire, or any part of the electrical equipment, you become a part of the circuit. That's when you receive a shock. An electrical shock in the movies raises a few hairs and a few laughs, but in real life, an electrical shock can be deadly, and there's nothing funny about that. You'll learn what factors make you most susceptible to receiving a shock later on. For now, though, it's safe to say that electricity is something to be respected, not feared. Always assume that the potential for electric shock is present and take the necessary precautions to prevent it. The following 8 guidelines will help you work safely with or near electrical equipment. The first guideline is to inspect your work area for electrical hazards daily. What should you look for? Flickering lights, sparking or smoking at receptacles, switches that are warm to the touch, the odor of something burning, loose connections. Take care of equipment, because improper handling and poor maintenance can pose deadly electrical safety hazards.
What's that smell? Something is burning.
I guess the machine's running hot.
Running hot? It smells to me like something's melting. If I were you, I'd shut it down right now and call maintenance.
Whoa, oh, you're right. Look, stay right here. I'm going to go make the call. First, I've got to shut it down.
If you detect an electrical problem, follow your company's procedure for reporting it right away. Never ignore an electrical problem. Failure to take prompt action could result in a fire or injury, which brings us to our next point. It's always important to choose the proper electrical cords and connectors for the job. By doing this, you won't be risking your safety by altering electrical equipment in any way.
Now, where's that heavy-duty extension cord? Well, I'll just use this one and bend the grounding prong out of the way. It'll do for now. There. This is just a quick job.
Rich made 2 serious electrical mistakes. First, he bent the grounding prong on the plug so it would fit the extension cord. Grounded plugs with 3 prongs are designed with safety in mind. The purpose of the 3rd prong is to provide a path for stray current to ground. Always ground electrical tools and equipment. Never modify a plug by bending or removing any of the blades. And never use a plug if the housing is damaged or the insulating device is removed. The second mistake Rich made was to use the wrong type of extension cord. There is a right extension cord for every job. Consider the equipment, its power requirements, the environment, and the cord's wire thickness and length. A good rule of thumb is to make sure that the extension cord's thickness is at least as thick as the equipment's cord. Be sure to take proper care of all electrical cords. Damaged cords cause thousands of electrical fires and injuries every year.
Hey, hold on there. Take it easy with that cord.
Look, I'm in a hurry, okay? So skip the lecture.
Don't you know you can damage the cord by yanking it out like that? You can even start a fire.
What's your problem today, anyway?
Hey, what's with you? Look, this one's really frayed. Looks like you yanked it one too many times. Better tag it for repairs before someone gets hurt.
I guess you're right. I should be more careful.
The only thing Bob did right was to remove the cord from the outlet when he was finished. But the manner in which he did it was all wrong. You must turn off equipment before you pull the plug. And don't yank on the cord, grasp the plug instead. Then gently rewind cords to prevent the interior wire strands from breaking. Now let's look at the next rule, which is one of the best ways to prevent electrical hazards. Read and follow instructions for proper use.
Oh, this'll take forever.
Hey, Marge, how you like the new office?
Great. I just wish they'd hurry and set up this computer. I've got a ton of work to do.
Oh, good luck. I'll see you later.
Yeah, Joe. I'll see you later. What am I waiting for? I could set this thing up myself. Oh! I got a shock when I tried to plug it in.
Well, why didn't you wait for engineering to set it up?
I figured I could do it.
Well, did you follow the instructions in the manual?
Well, not really. I just plugged it in.
Look, any attempt to set up and operate any electrical equipment without reading and following all the instructions could result in an electrical shock. And in this case, you might have damaged the hard disk drive as well.
This rule applies at home as well. How many of you have attempted to set up and operate or repair an appliance without reading the instructions? It's a common violation of electrical safety rules. You should always read and follow operating instructions before you use any electrical equipment. And be sure to get professional advice if you have any questions. Which brings us to our next point. Leave equipment repairs and adjustments to authorized personnel. Don't tamper with or try to install electrical devices or equipment. Notify the appropriate personnel and leave adjustments to them.
Hi, Bill. This is Doris. There's a problem with the outlet next to my machine. You think you can come down and take a look at it?
In the meantime, prevent others from receiving a shock. Warn them that there is a problem. This brings us to our next point. Follow required lockout, tagout procedures.
I don't know. It's making this grinding sound and then it just stops.
I better take a look at it. First, I'll have to lock and tag it out.
What is lockout, tagout? When you're blocking the flow of energy from the power source to the equipment and keeping it blocked, that's lockout. Tagout means placing a tag on the power source to warn others not to turn the power on. It's always necessary to lock out, tag out to prevent the accidental startup of electrical equipment. The first step in a lockout, tag out procedure is to turn off the equipment and disconnect the energy source. Use a lock to prevent the flow of energy from being restored. Test to make sure it can't be put in the on position. Even though you're using a lock, it's also important to place a tag telling others who you are and what you're doing. Release stored energy that could cause sudden movement. Test it again to make sure no power is getting to the machine before working on it. When you've finished working, check to make sure all tools have been removed, all lines have been reconnected or unblocked, all guards have been replaced, and other workers are safely out of the way before removing your lock and tag and turning the machine on. Let's take a look now at another way you can protect yourself. Always use the appropriate protective equipment.
As an electrician, I know the dangers of electricity. That's why I never wear rings or other jewelry on the job. because the metal can conduct electricity. And I always use personal protective equipment. Those of us who work on high voltage equipment wear rubber gloves and check them for punctures, tears, or abrasions before starting any job. We also wear leather protectors over the gloves to protect the rubber. As important as wearing the right protection is, there's no substitute for following safe work procedures. Remember, failure to do both could result in electrical shock or burn, or you could even die.
As we said earlier, electricity takes the path of least resistance. The body's resistance to electric current is almost all in the skin, and the skin's resistance is reduced by water, which is a good conductor. That's why the 110-volt house current might give you a small jolt if you have dry hands, but can kill you if you have wet hands or feet. Rubber gloves, rubber-soled shoes, or a rubber mat can block an electrical path. Always use appropriate protection. Now, here's something else you should always take seriously, even though it may not sound like a very serious subject. Practice good housekeeping. Take a look at this work area and see if you can identify electrical hazards that have been created as a result of poor housekeeping. Be aware of the hazards that electricity can create in otherwise safe environments. For example, keep metal ladders away from electrical equipment. Never store flammable materials around electrical equipment in order to prevent explosion or fire. And don't leave spills on the floor. This could create a shock hazard. In addition, don't leave anything in contact with live power sources. This brings us to our final and most critical point: what to do in case of an electrical shock.
Are you all right?
Learn what to do in an emergency.
Bill!
No, don't touch him!
Don't touch the victim until the power has been disconnected, or you'll get a shock too.
Shut the power off.
Know where and how to shut down the power in case of electrical shock. Know who to call for help, and be able to give exact information to emergency personnel.
There's been an electrical accident.
Administer first aid and/or CPR. If you aren't qualified to do so, find out now who is. Fortunately for this victim, his coworkers knew what to do to help. In many cases, the victim may be saved by quick action on your part. It's recommended that persons working on or near electrical equipment get training in artificial respiration and CPR. One excellent source of training is your local Red Cross. But remember, never touch the victim until the power has been turned off, or you'll become a part of the electrical circuit and receive a shock too. If you can't shut off the power, call maintenance or the electric company. Obviously, since electricity is such a big part of our lives, electrical hazards are a real and present danger. With that in mind, let's take a moment to quickly review the actions you can take to prevent the most common electrical hazards. After all, the more you know about electricity, the safer you and your coworkers will be. The first guideline in preventing electrical hazards is to inspect your work area. Be sure to choose the proper electrical cords and connectors for the job. Always read and follow instructions for proper use. Leave equipment repairs and adjustments to authorized personnel. Learn and follow required lockout, tagout procedures. Don't forget to use the appropriate protective equipment. Practice good housekeeping at all times. Know what to do in an emergency. Learn first aid procedures and precautions for assisting others. You've seen why it's so important to respect the power of electricity. So follow these rules at work and at home. Never second guess when it comes to electricity. Remember, electricity travels at the speed of light. So think before you act and treat every wire as if it were a live one.